What is good, my analysts? Today I want to talk about scheduled tasks. And actually, I want to go back a couple years to go over a Microsoft blog in which they detailed a piece of malware called Tarrask. And Tarrask did something very interesting as an evasion technique to hide itself from common audit tools like Autoruns and the Task Scheduler GUI by removing a registry value called SD. Now, I started thinking about that, and when I realized that the data within the SD value is actually just the binary representation of a DACL in Windows, I thought, what else could we do with this value to see if we could kind of evade some of the guidance as far as detection, and then what we could do as an additional sort of detection strategy to build upon that if we're able to find any gaps. So very quickly, we'll just highlight kind of an overview. I don't want to recreate everything that Microsoft put in their blog. Well, I'll link to it below. It's a great blog. You should read it. So very simply, let's go ahead and create a task. We'll just call it evil task. It doesn't really matter. And if we go into the registry here and refresh, we'll see our evil task right here. And if we delete this value, we'll see that evil task will disappear from task scheduler. It would also disappear from things like Autoruns if I wanted to do that. Now, from a detection point of view, there's a couple different ways we can do that. So they've recommended a couple different things. So first of all would be to Windows event log, which is not enabled by default, either one of these. So it would be 4698. And if we, oh, I almost messed up. Caught it. 4698 in the security log, we'll see a scheduled task was created. Also in the task scheduler operational log, that would be event ID 106. And then they also did another one, which relies on, and this is a Sentinel query, a KQL query, but basically it relies on registry monitoring, which is also not enabled by default. You have to enable that within the registry through group policy, or you could do it through some other capability. But if you look at the permissions here, go to auditing, everyone, you need to audit set value and create subkey to get the requisite telemetry. And they have basically it's the 4657, which is the event ID. And then what basically looking for any events where the object that is deleted is SD, right? And the path is contains the tree, the scheduled task, and the operation type was reg value deleted. So that's very quickly how you can go about recreating that, making sure you have the requisite telemetry that aligns with the Microsoft guidance. And then there's also a way, let's say if you were an incident responder and you didn't have any of this data, to kind of audit the registry in itself. And that's basically to go ahead and collect all of them, evaluate the SD value, evaluate to see whether or not any of them didn't have an SD value. And we can see evil task comes up immediately, right? So what I started thinking about is like, well, what if I just put any sort of junk data in the SD value? Would I get the same sort of output? So let me run this. It's going to create a scheduled task called stealth dewire. Now we have something that will evade. We only get evil task in there. If we go into the Windows event logs, we should get an SD is modified but not deleted. And I looked at the actual logic in the detection and it is for deleted, but I was able to register a scheduled task. I will not have a 4698, even though it is registered, even though it is installed. See, I don't get a new scheduled task that is created. So I was able to evade the new scheduled task event ID, sort of evade the registry monitoring. You do see that I set an SD value, but it doesn't align specifically with the logic. So we'll take that into account. That we also need to look for processes that are modifying the SD value. Now, As a note, I am running as the local system account here. You do need to be leveled up to system to make changes to this registry key. But given all the tools that are out there that allow you to go from admin to run a system, as well as the prevalence of bring your own vulnerable device driver kind of things prevalent, it's not that uncommon for an attacker to get system level access on an endpoint. So that's very interesting, but we're still able to see it in the telemetry. But if you're an incident responder, you try to run that PowerShell query, then it's not going to work. So I'm going to show you a little thing here where we can evaluate what is actually in the SD value to see if something is junk or if it's a legitimate one. So I have a task in there called safe task that's just doing it's normal. It's not evil or anything, and everything's going to be set right. So we can use some of the WMI helper classes that are accessible in PowerShell to basically query it and say, oh, look at that. I got an object back that is an actual stackle, right? Here's all the properties in here that we'll go into those later, but it is legitimate. It's a Win32, translates properly. But we can just say, let's take SD value here, and I'm just going to delete all this data. So it is junk, right? Now it's not a valid DACL anymore. And if I do the same thing, so let me go ahead and take a look at it. I do that again. Now it's null, right? So there's an instant check where you can kind of say, if I get an actual DACL back, then it's probably okay, right? What else could we do with that, right? So let's take a look at what the actual DACL looks like again here. So if I have my safe SD, it should just be, well, I'm going to have to recollect it because I reset it. If you look at safe SD value, it's just going to be a binary array, right? But we can use the helper classes here to actually take a look at the SDDL, which, if you're not familiar, is a syntax in Microsoft to write DACLs to different objects, files, whatever it's going to be. And you can Google it, right? And so this is going to look like, if you've never seen this before, it's going to look like junk. You can Google it. There is an actual syntax. And here's this O colon means the owner is the built-in administrator group. And if you get into the parentheses in here, these are basically the actual DACL on this, the owner in the group. And then these are the individual access. And all you really need to know for this example is A colon means allow, right? Allow, 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 allow. So to deny something, right? To create a valid DACL that would deny access and essentially get the same result where it would be hidden from task scheduler, it would be hidden from Autoruns because the system won't be able to read it. And that's why this evasion works, because it can't read it and it won't show it in the tools. All we need to do is write a valid DACL to the scheduled task to the SD value. We would get the evasion, and then we would bypass sort of enumerating through there looking for junk DACLs. We wouldn't get a new scheduled task created because you can just write the registry keys. Now, the one thing you have to do for that is restart the task scheduler service. So that is something you need to be keying in on, is looking for anomalous service restarts of this, because if they are writing scheduled tasks to the registry, they won't run until the task scheduler service restarts. So either the system restarts or they manually restart it. So I was thinking, I wonder if there's a way to do this all alone. And then I thought, well, we know that we can get around the detection for deleting the SD value. We will still get some telemetry in there that we modified it. But the real indicator there, the real hang up part is that I have to restart the task scheduler service. Now, in Windows 10, one thing that we were testing out here is that if I hijack an existing service and just change the actions by basically writing my own binary that says, let's see. Let's see if I show this to you right now. So save task currently runs calculator, right? And if I just say I want to run PowerShell instead, I can make that binary data, convert it to the right sort, and then I'm just going to write that value to the registry, set my deny SD. You can see I changed these all to allow to deny, 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 deny. And let me just, before I remove it from everything, all I'm going to do is change the actions, right? Just by modifying a registry key. So let's go ahead and run this now, and I'll show you what that looks like. Okay, so if we go back in save task, and if I go ahead and do a refresh, now I'm running PowerShell instead. Now, if I want to remove it from, so no one can look at my stuff, all I got to do is take my define deny SDDL data, convert that to the right sort of binary data, write that binary data to the registry key, go like this, and it will disappear from Autoruns. It'll disappear from the scheduled task GUI, and etc. And it has a valid DACL, right? So we'll get that object back. And I will still get, though, like if I go back into here, with registry monitoring, I'm still going to see that an entry was modified. Now, the detection that's out there right now is for deleted, but maybe we need to extend that to modifying that value, especially for certain process names. Well, in my case, I'm just using the built-in tools. I'm sure someone much smarter would write a piece of malware to do this so they could make it look like whatever, but we do want to look for system living off the LAN tools and modifying this key, because you're able to get the same effect without having to actually delete that key. You can just update it, not write it at all, or put junk in there, right? So those are three sort of considerations what we need to consider, as well as the deletion. Now, this is where things get very interesting, especially for Windows 10 systems. So if I go to keys, right? I have a scheduled task with the deny SDDL data already kind of prepackaged. It's already prepackaged to evade this, to deny from auditing. And all I'm going to do, and from another computer, I changed the generic names, exported it, and now I can do an import tree here. And I'm going to write my stealth dwyer task to the tree key. But here's the kicker. In Windows 10, when you import data into the registry, it will not be logged at all for registry monitoring. You won't get any sort of 4663. You're not going to get your 4657. You're not going to get a new scheduled task that was created. This happens completely in the blind for Windows 10. Windows 11, this bug has been fixed, tested it, verified it. When you import, you also need to restart the scheduled task service. But that's pretty scary, because now you can basically get to a point where you are able to add a scheduled task. And if you don't catch that service restart, especially if you're an incident responder, like you won't have any log saying that this was modified. So what we can do about this, actually. So let's go ahead and take a look at what happened here. When I wrote that, when I imported it, it will have this valid DACL. I mean, it is a legitimate DACL. It's just saying to deny, right? So we need to dig into this a little bit further to get what we can key in off of. So all I'm doing here is getting the value for this tab, getting the SD value for this task, and then I'm going to use a different function here, which is the descriptor function, which it basically allows me to dive into the security object in and of itself. Okay. So as long as this works, we should have a valid security object in PowerShell as an object, and we do, right? So if I go to I can go to group.name, and it's a none. Now, in my searches, that's totally common on legitimate tags. On a little bit legitimate tags, they don't always have an owner. If I are not owner, they always have an owner. They sometimes are none for group. but they will always have an owner, right? Administrators, by default, that's how it comes in if you create a new one. So this looks good. Um, the other thing we can do is like look at the trustees, right? Basically saying, well, let's make sure that the system account is listed in the DACL. We see system, my user account, administrators are all in there. So everything looks right to this. So the only way you can kind of do this is, as long as I did this right and I imported the right key, what we'll see here is we actually got to dive into the DACL and then do a lookup to say, for every trustee name, give me the ACE type. And if ACE type is 1, that means it's explicit, it's like specifically denying that trustee name from whatever it is, right? And by default, like we really shouldn't be seeing deny access in scheduled tasks ACLs. So let's give this a whirl. And we can see system, this is the big one, right? System is being denied access to this. And so what we'll have to do here, especially for the incident responders out there, is that we really need to sort of go through there. Like if you don't know what's going on, you can't rely, like this is not going to show up in Autoruns. It's not going to show up in the Task Scheduler GUI. So like, what are we going to do about stealth to wire here? Well, fortunately, I wrote a little bit of a script here to put this all into all of the different tactics, starting from the ones that we know about, going to the ones with a junk value, going to the ones that, would have something removed, like just removing the system from there, all the way going down to explicitly denying administrators or system from doing it. And it's a script that you can run, and it doesn't take long. It takes like a second or so. So I'm going to run it. We'll come back and I'll show you what it looks like at the end. Okay, so it finished running, maybe took like a minute or so for it to run. You can see that it went through and enumerated all. We have our first eval task with the missing SD value. And then it go through and says, hey, I took a look at the DACL on this task and I see that administrators was explicitly denied. So let me flag it. And it's going to check that because at 3 different times you could see administrators and system there was denied access. You're going to get 3 different results. Then it goes back through and checks the registry again because we can't get it through Autoruns or anything like that. It does the decode and gives you what the actions of the task are. I'm going to put this up on our GitHub repo. So you can go ahead and use it, modify it, make it better, probably, because I'm not the best programmer in the world, but there's an idea and approach to go ahead and do this, especially for my incident responder fam. If you ever get put in there and you don't have any sort of telemetry, I got you. We'll put this up there and you can start hammering away at it. So takeaways from here is that Microsoft guidance was really good, but expanding on that, there are further capabilities to build upon what the Tarrask malware was, which is, you can write junk SD value, SD data, you can import stuff, you can create tasks manually, and the other things that we need to key on. So we need to be very cautious or very aware of the system account doing things like running command interpreters like PowerShell or command or Wimic or any of those other kind of things, modifying the registry directly, importing registry keys. We also need to start looking for that SD value being modified rather than just explicitly deleted, because you never know what you're going to have to do. And then potentially, we now need to consider actually auditing the DACLs on our scheduled tasks to make sure that we are able to find out anyone that's very much being explicitly denied access to that. That would be very anomalous. And finally, did I say watch for the task schedule service restart? If not, I'll repeat it just because it's that important. Make sure that we have detections in there looking for the system account, restarting the task scheduler service, especially if they're doing it from the command line. Until then, blogs below with more details. Happy hunting.